So with verifying trig identities, okay, you have, and a lot of stuff is things that we've already seen. It's just basically what we're going to do is we're going to verify everything, okay, by using equations or taking one side of an equation or two sides of an equation and basically showing that they are going to be equal to one another. Okay? Remember, an identity is just showing that things are going to cancel their way out to where in some cases it could equal 1 or it could equal a certain type of value, and with different things. We've already talked about reciprocal identities of sine and cosine and tangent, and of cosecant and secant and cotangent. Okay, a lot of, bless you, is stuff that we have already seen, you've already done. Now it just comes to the part of basically just verifying everything. Okay, the reciprocal identity is one of the first things we learned back in chapter 4 whenever we kind of introduced all the trig functions. And then same way with quotient identities, basically that tangent is just sine over cosine and cotangent was cosine over sine. Okay, we talked about it last chapter about being like y over x and then x over y for cotangent. You got a little bit of an introduction to the Pythagorean identities here in the third part, where it talked about sine squared x plus cosine squared x is equal to 1. Then whenever we do the same thing, we had 1 plus tangent squared x is equal to secant squared x, and then 1 plus cotangent squared x is equal to cosecant squared x. Okay? We really didn't use those a whole lot, as we really just introduced everything to you. And then the last thing was just even and odd identities. Basically that if you had the ones that were odd, that if you plugged in a negative, you got a negative. As far as tangent, cotangent, sine, and cosecant. Whereas whenever we dealt with cosine and secant, basically if we plugged in a negative value, then we still got the positive form of it. Okay, that really didn't change. Again, these are all things that we've seen at some point. Maybe we've talked about them, most of them, especially the second half. We really haven't worked much with them. We kind of did with the even and odd, basically just saying, hey, if we plug in a negative value, that since it's cosine, mainly cosine, not so much secant, but since it's cosine, it's still going to be a positive value. Okay? Regardless of what x value we plug in. Okay? So basically what's going to happen whenever we verify an identity. So when we verify an identity, basically what you're going to do is you're going to use the identities that we had in the table before to manipulate either one or both sides of the equation to basically just show that they are equal. Okay? It's essentially a proof, but without like justifying it. Like you don't have, whenever we were in geometry and you were starting with proofs, you had to like verify certain information and say, it was alternate interior angles if we were talking about parallel lines or congruent angles, things like that. Where here we really don't have to say what the reasoning is, we just kind of can go with it. So a lot of this, you may do some things different than what I would. Okay? You may do the exact same thing. You may kind of go around it in a little different manner, which is completely all right. Okay? It's one of those things, don't overcomplicate it and kind of go with what you know. Okay? The majority of the time, what's going to happen is you want to turn it into, the one's going to get used the most, especially if you have sine, cosine, tangent, or sine and cosine especially, and then secant and cosecant, is you're probably going to use the reciprocal function a lot. So then you can get things to cancel. Basically, you're just going to turn it into a fraction so you can get either numerators to cancel, denominators to cancel, and kind of go from there. Okay? So whenever I do this, what's another way of writing secant? Just the secant part, not forgetting everything else. Is there more than one way of writing just secant of x? 1 over cosecant. Okay? So if I go 1 over cosecant of x, what's another way of writing cotangent? Tangent was sine over cosine, so what was cotangent? Cosine over sine? Now, what I would suggest here is leaving the cosecant kind of by itself and go from there. And just kind of see how the left side plays out. Can anything cancel on the left side? Is there anything on the left side right now, or do I need to manipulate something or change something right now? Did you say cosine, Sam? And I wrote it down. Okay. All right. So it should have been cosine, not cosecant. There's where now we can get things to work out. Thank you, Rachel. So now is there anything that can cancel? Again, it's just two fractions is all I'm really worried about. Or all I'm really working with. Do I have a numerator and a denominator that can cancel each other out? One on top, one on bottom. Yeah, what's going to cancel? The cosines. So the cosine here and the cosine there are going to cancel, which is really just going to turn everything on that left side into 1 over sine of x What is 1 over sine of x? Now it's cosecant. So then the left side is equal to the right side. Okay. In some cases, we won't have to do anything to one side of my equation. Okay, and that's all right. I would tell you the one thing that I would suggest is try to limiting yourself to only manipulating one side unless you have to do both. Okay? If you can just worry about one side and focus on one side of your equation, then that's going to be your best bet. Because the less that you have to do, the better it's going to be. The one thing here at the bottom basically says there's no one way to verify the identity. We already kind of talked about that. You can go a lot of different directions or a lot of different routes. Sometimes it could be trial and error. But a good strategy to have is I would try to change anything you have and not necessarily into sines and cosines. Those are going to be your best bet because you can always write any of your 6 main functions. You can always write them in terms of sine and cosine. Okay? You can always write them in terms of sine and cosine because sine is sine, okay? Cosine is cosine, tangent is sine over cosine, and then the sister functions or the reciprocal functions are just the reciprocal 1 over sine or 1 over cosine or cosine over sine. Okay? So we can turn everything we need to into that same value, or using sine and cosine. It's not always going to be the case, but that's probably going to be your best bet. So then again, everything here are fractions. Okay? What's another way? I already have sine of x. What's another way of writing tangent of x? Okay, remember that the first two parts are getting multiplied together. But what's another way of writing tangent of x? Sine over cosine. So then I have sine of x basically over 1 times sine of x over cosine of x. What is going to happen up top? If we just focus on the first part, what's going to happen with sine of x times sine of x? How many sine of x's do I have? 2. So I'm going to have sine squared of x over cosine of x. Now there's nothing really I can do with that left side. If I want to ever add, so if I just have cosine of x basically over 1. If I want to add any sort of fraction, what do I have to do to add any two fractions together? Have what? Common denominator, right? So what do I need to do to this first part right here? What do I need to multiply the top and the bottom by? Cosine of x over cosine of x? All I'm doing is really manipulating everything. So I'm going to have sine squared x plus cosine squared x all over cosine of x. Did I get anything, either the top or the bottom, mainly the top, that's from that yellow box at the very beginning, or something that you've seen before? What? Pythagorean identity, right? So what is the Pythagorean identity? Yeah. Sine squared x plus cosine squared x is equal to 1. So I have 1 over, okay, this part right here is just equal to 1. So 1 over cosine of x is equal to everything on that right side, which is secant of x. What is 1 over cosine? Isn't it just secant? Okay. And it may be one of those things that you manipulate the secant of x, okay, and you go ahead and change it to its other form, so then you can kind of see where you're going. Does that make sense? Okay, so like if we would make secant, like before we start, make it 1 over cosine, because we can always change it back. Okay, we can always change it back to what it originally is if we don't. So then you kind of have an idea of where you want to go. Okay, or how you can kind of get there. Whenever you wrote proofs, because I know I didn't have any of you. Did you guys, were you ever taught to basically, so like what I mean is basically if I just have like the left side, okay, in this one we're going to factor, but like if I just have the left side and I kind of separate everything out and I make it cosine of x, I did not like that, cosine of x minus cosine of x times sine squared of x. And then if you want to put kind of like the end statement, like where you're going towards the bottom, and say that we need this thing to equal cosine to the third, or cubed, x. So if you want to kind of stack everything, instead of setting it all equal to each other and just manipulating one side, and you want to stack it and basically say, look, I've got to start at the purple side, or purple part up top, and I've got to make this thing look like cosine to the third times x. So that way, if at any point you get stuck, then you can kind of go from there. Okay? So obviously it says we're going to need to factor. So what can I factor if I just start at the top? There's really nothing I can do on that bottom side. There's really nothing. I mean, I could write out cosine squared, or I could write out cosine to the third, and I could show that it's getting multiplied by itself 3 different times. It's not really going to do me any good, though. That's going to be a lot of wasted effort and that sort of thing. So you always want to kind of start at the top and then work your way down. The one thing I would tell you is the only reason you would come from the bottom up is if you get stuck at some point kind of in the middle and go from there. So if I have cosine x minus cosine x times sine squared times x, is there anything that I can factor out of the top, or the purple part? Like what's in both parts, like with the subtraction sign? Cosine. So I can factor out a cosine and have 1 minus sine squared of x. Don't forget the x here. My fault. So we factored. I need 3 cosines. I have 1. Where are the other 2 going to come from? What does this look like anything that we've seen maybe? Or something similar? Yeah, it's a Pythagorean identity, right? Okay. The Pythagorean identity, however, says, and I'm going to write it over here to the left, says that if we have sine squared of x plus cosine squared of x, it's equal to 1. How do I make what's in the red on the left side look like what's in the red on the right side? Just send that over to the other side, right? Isn't this the same thing as cosine squared x is equal to 1 minus sine squared x? I'll give you a hint. If you have a sine or a cosine squared, or a tangent or a secant squared, or a cosecant and a cotangent squared, you're going to use a trig identity. Okay? Especially if there's a 1 involved, you're most likely going to have a trig identity. Okay? I will bet money on it that that's going to happen. So what are we going to turn what's in the parenthesis? What are we going to turn it into? What's that part that's highlighted in the yellow going to turn into?
Cosine squared of x.
Yeah. So I have cosine of x times cosine squared of x. So I have a cosine times a cosine squared. So how many cosines do I have?
3.
3 of them. Here. Just like a proof when you were in geometry, they may be 3 steps, they may be 4 steps, they may be 6 or 7. They may be 2. It's just a matter of, and I will tell you that I'll have some students that will be more apt to probably stack it and go that route, so then they can kind of figure out how they want to fill everything in. Okay? A lot of this is really just turning things into maybe either a fraction, or most likely for right now, a trig identity. Okay? Or a Pythagorean identity, excuse me.